Hi, I'm Taha, and welcome to this series of implementing retro gaming on FPGA. So, to cut it short, we're not going to talk about the basics of FPGA, as I think there are more expert people than me to teach you this stuff to you. So, feel free to search it on YouTube and watch them if you're not really familiar with the basics. What we're gonna focus on in this series is this tiny board, if I can show you. The Tang Nano 20K from Sipeed, which the 20K refers to the fact that it has 20K lookup tables. So this video is dedicated to introduction of this board. If you just search it up on the Google, you can find the wiki, like Wikipedia format of this company, Sipeed, which explains a bit about like the pinouts, the parameters, and stuff like that. And as well, you're not like out to like buy the 20K version. You can as well go for the 9K or 4K. But I kind of recommend to buy the 20K version as we proceed in this project. We'll probably need more lookup tables, so I think like the 4K version wouldn't suffice in the future. The 9K version, I think it would be good, but if you can just go for the 20K, the prices aren't mentioned here, but I think it was like 30 or 35 bucks, which is like kind of cheap for like, dude, it's an FPGA. So yeah, if you can just go for the 20K one. So as you can see, like from the parameters table, it has like 20K lookup tables of size 4, 15K flip-flops, like what is it, like 5 megabytes of SRAM, and blah 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 blah, like 48 multipliers, 2 PLLs, and stuff like that, which is like probably good enough to like implement a simple retro game. It has like 6 LEDs. I will like connect it so you can see it better. 1 second. As you plug it in, like they start to glow in a this kind of format. There's 6 LEDs to what's going on my PC. They start to glow up, and there's as well one single if I can show you and it don't get disconnected again, a WS2812 RGB LED, which we'll be talking about on the next parts. We can like make it like go RGB console shit to make it glow up a bit more. It has as well 2 keys, like as you can see, S1 and S2. And the sad part about all of these is the fact that both buttons and the LEDs are active low. So yeah, keep that in mind. And yeah, it has an HDMI output, the speaker output, the buttons, the USB for the JTAG to upload the program, flash, and yeah, TMDs for the HDMI and stuff like that. So you can read it as well here. I'm not gonna like talk about it much more. Here's the pinout, like the DC 5 volt and the GND, and these signals for the controllers if you want to like connect some. The fun fact that I really enjoyed this board was that the developers like did in fact, like you can see here that it's actually saying the joystick, like they actually had an intention to build this for this kind of stuff. So yeah, that's why. But the sad part is like there's like literally zero resources on the internet to learn about how to connect the joystick to it and uh, like load the programs. So that's why I decided to record these videos. I hope like I'm learning as well. Just to that's the disclaimer here. I'm not like really into it. Just trying to learn as well and share them with you guys here. So going down, we can see the datasheet and schematics which I've downloaded here. And the first part, let's talk about. Okay, no, this is boring. Let's just get into the board. So when you connect it to the board, to the laptop, it has a soft core like programmed into it. It's called LightX, which has some basic instructions. If you just open up your device manager and see what it is connected to, for me it is like COM11, or you can use any other serial reader application, but I prefer to use PuTTY. And put the baud rate speed on 11.5200. And yeah, as well keep this on never so it doesn't just closes. So as you can see, it just pops up when you press tab. You can see the instructions. We're just gonna quickly like use one. You can explore the others as well. There is also an explanation on what these do here on the unbox part. You can read this as well. We're just gonna test this one real quick. So when you type LEDs, it says it has a parameter. So we're gonna type one. So as I told you, it's like reversed as it is active low. So if we type like LEDs to 63, as you can see, it just turned off as it is active low. But if you type LEDs, you can as well type it in hex, doesn't matter. If you type LEDs, for example 1, you can see all the other LEDs glow up except for the one active low. Sadly, if you type LEDs 62, it only shows the one, as it is the 2's complement of 1. So yeah, and you can also explore other instructions, but we'll just leave it here. Close, yes. So now let's just go to the IDE. You can just follow these stuff and install the IDE. It's pretty straightforward, and this part is important, keep this in mind. And after you installed it, also be careful to install the education version so you don't have to deal with licensing stuff. So when you open up this Gowin, I don't know what it is. So when you open it up, you can use some example projects, but we're gonna just make our own. You just go to the FPGA design project, press OK, and like name it as what you desire, like test LED. Here's the part that I told you to keep in mind. Here it is. So look for the Nano 20K or whatever version you're using, and just put this here. The one we're using is GW2AR. The device is here. We're using the C1. The package is this, and you're using this one, or you can just find it here. You press next, and we're done. the project is created, and we can now make a Verilog or VHDL file. Go with whether you're more comfortable with, but we're gonna go with Verilog on this series. I'm gonna name it LEDs. Add to the current project. Okay, so I've prepared a snippet of code here, which like goes to implement a simple circuit. It just uses one of the buttons to count up and show it on the LEDs. So as you can see, we have a clock here, and we have a button defined, and 6 LEDs. I've defined a pushed register, or whatever you want to name it, to like kind of avoid any bouncing. Like if you don't know what bouncing is, like the code goes like this. At any pause edge, it just checks for the button. If it's pushed, it just adds 1 to it. But as you're not Sonic, and the clock is about 27 megahertz, I guess. So it like literally counts up until you unpress the button, which you can't like do it in one clock. So it gets added and added, like it may become a random generator somehow, the pseudo random. So we just add a pushed register here to make it like keep it here. It's like a while loop in somehow higher level software programming stuff, to hold it here as long as the button is not pushed, is pushed. Sorry. So 2 things here are important. As I told you, the button is active low, so we have to say when the button is not like pressed, which means the button is pressed, and the button is not pushed, as it is 0. Add 1 to LED. So here as well, we have the LED as an active low entity. So we have 2 ways to add 1 to it. We can like make it -1, which means like adding 1 in an active high situation, or this like method, which I'm more comfortable with, just inverse it, like the 2's complement, make it like increment it, and just make it go back to the way it was by taking another 2's complement, which like makes it easier to work with, I guess. But feel free to go with this one if you wanna. So when the code is done, we just press Ctrl S. We come to the process part. We press synthesize to make sure it works properly. No, it's nothing too important. It's okay. We're okay with the truncation. So it's synthesized now. Now we have to give these inputs and outputs some pins. Just click on the floor planner here, and it says you don't have any CSD files, so press OK to create one. Now when this pops up, just go to the IO constraint, make this a bit wider. Now we're looking for the pins, so come back again here, and at the bottom of introduction part, you had the schematics, and download that one. And as you can see, here's the schematics of the board, which you can find the pin names here. The key S1 and S2, which is connected to pin 88 and 87. We're gonna go with 88 here. Just press enter and the other like stuff gets filled. Oh, by the way, like I'm not sure what's going on. I'm learning as well in this series. I'm not like any pro in this field, because this board is like I don't know what it is about it. It came like in 2023, I guess, and it has like zero source on the internet. So I'm like really trying to find it myself, but it has some options on the pull mode, like pull down, pull up, but it doesn't matter what do I put it on. It just keeps getting pull up in the real world scenario. So as now, I won't just change down, but I'll keep looking for it to understand and then explain it in next videos. So we set the button. Let's look what the clock pin is. So if you come down here, you can see the oscillator of 27 megahertz is connected to pin number 4. So you come here and type 4. And now we want the LEDs. We go back up here. The LEDs are connected to pin 15 up to 20. So we just go 15, 16, 17, 18, 19, and 20. Just press Ctrl S and you can close this part. Alright, going back here. Now place and route. Click on that one. Wait for it to do the things. And we're good. It gets checked. You can as well like check the sensitized report or these reports as well to see how many resources it used. Like for example, 7 registers as flip-flops, and how many lookup tables, like one lookup table of 3, 5 of 4, blah blah blah, stuff like that. And now press program device. It will be automatically set if the board is detected, so just press save and click on the program and configure, and it will upload the bit stream on the FPGA. So I just uploaded it. So as you can see, sorry, I guess it got disconnected or no. Alright, it's set to 0 as we had it in the code. Like if we come here at the initial part, it's set to 0, and when you press did we set it to S2? Oh no, S1. The 88 bytes is S1. So as you press it, it just gets counted up. It goes until it ran out of the bits and goes from the 0 again. It's gonna take a while. Sorry. There you go. So yeah, that's it. A simpler project on the board, so you get familiar on how to write the code, synthesize it, set the pins, place on route, check the reports if you wanna like optimize your code, program it, and test it out. And yeah, that's it. I wanted to keep this video short and simple. We're gonna talk about the HDMI port and interface on the next video and show some stuff on the screen. And by the way, if you are following up with these videos, just don't forget to buy a heatsink of size, I think 9mm or 10 ish. Just size it for the main chip, because it gets really hot when we start to use the HDMI interface. So yeah, keep that in mind. And yeah, that's it. Thanks for watching, and I'll see you in the next one.